Voyager 1 spacecraft, a symbol of human curiosity and ambition. Launched in 1977, Voyager 1 was part of an extraordinary mission that would go on to define an era in space exploration. Together with its twin, Voyager 2, it was built to explore the outer planets. But what it ultimately achieved surpassed every expectation. The Voyager missions marked a watershed moment in the history of space science. Designed initially to conduct close-up studies of Jupiter and Saturn, these pioneering probes delivered breathtaking images and unprecedented data, transforming our understanding of the gas giants and their moons. Yet, even as Voyager 1 completed its original mission, it kept going, pushed onward by the relentless drive of discovery embedded in its very design. Voyager 1's journey did not end at the edge of the solar system. Instead, it became the first man-made object to enter interstellar space, crossing the heliopause, the boundary where the solar wind gives way to the interstellar medium, on August 25, 2012. With this historic achievement, Voyager 1 stepped beyond the protective bubble of our sun's influence into a new and uncharted realm. It was a leap not just across space, but across the boundaries of human knowledge. As it travels more than 14 billion miles from Earth, Voyager 1 continues to send back signals, whispering secrets from a region of space no other human-made craft has ever visited. It relays vital information about cosmic rays, magnetic fields, and the density of interstellar plasma. Clues that help scientists piece together the nature of the space between stars. But Voyager's legacy is more than just data. It is also deeply philosophical and symbolic. Affixed to the spacecraft is the Golden Record, a phonograph containing sounds and images selected to portray the diversity of life and culture on Earth. It includes greetings in 55 languages, music from across the world, and even the brainwaves of a young woman in love. This record is a message to the cosmos, a hopeful gesture that speaks to our species' longing to connect with whatever might lie beyond. In every sense, Voyager 1 is more than a spacecraft. It is a time capsule, a sentinel, and a storyteller. It has witnessed the auroras of Jupiter, the rings of Saturn, and now the strange silence of the interstellar deep. Its journey reminds us that exploration is not just about where we go, but what we learn about ourselves along the way. Even now, over 4 decades since its launch, Voyager 1 continues its odyssey, a tiny speck in a vast ocean, sailing ever farther into the unknown. It carries with it the dreams, questions, and hopes of a planet bound by gravity, but driven by imagination. As long as Voyager 1 speaks, even in the faintest signals, humanity is still out there, listening, learning, and reaching for the stars. Voyager 1, the unstoppable explorer, and a recent cosmic silence. Voyager 1's epic odyssey through our solar system and beyond is nothing short of legendary. Over the decades, this pioneering spacecraft has peeled back the veils of cosmic mystery, unveiling long-hidden secrets that have deepened our understanding of the universe. From the swirling storms of Jupiter to the icy rings of Saturn, Voyager 1 has offered us front-row seats to the most majestic sights in our solar neighborhood. But its greatest achievement lay ahead, when it crossed into interstellar space. Voyager 1 shattered the final frontier, becoming our first messenger to venture beyond the protective bubble of the sun's influence. And even now, more than 45 years after its launch, Voyager 1 continues to surprise us. Scientists across the globe are still interpreting the groundbreaking data it transmits, confirming new findings that have the potential to revolutionize astrophysics and reshape how we understand the cosmic environment that surrounds our solar system. Every byte of information sent back from this tiny spacecraft, now over 14 billion miles away, is a treasure trove for science. The legacy of the Voyager missions is monumental. They stand not just as triumphs of engineering and science, but as symbols of humanity's insatiable curiosity and unwavering desire to push boundaries. They are beacons of inspiration, reminding us that even the smallest emissaries can carry the weight of our greatest dreams. However, Voyager 1's journey has not been without challenges. Recently, the mission encountered a puzzling interruption. After decades of steady communication, the spacecraft began sending back distorted data to Earth, signals that confused even seasoned mission engineers. It appeared that Voyager 1's telemetry system, which reports on the status and health of the spacecraft, was malfunctioning. For a time, it was as if our voice in the stars had gone faint, as if a long-trusted friend had grown distant and unrecognizable. But in true Voyager spirit, the story didn't end there. The incredible team at NASA's Jet Propulsion Laboratory sprang into action, navigating decades-old software, ancient hardware, and limited resources to diagnose the issue. In a feat of modern-day engineering wizardry, they managed to recover, contact, and restore normal communication, once again proving that even across unimaginable distances, human ingenuity can bridge the void. So join us in today's video as we dive deep into the story of Voyager 1, its triumphs, its mysteries, and the remarkable resilience of both machine and mankind. From its humble beginnings on Earth to the farthest edge of the solar system, this is more than a mission. It's a journey into the very soul of what it means to be human. The stars still call, and Voyager 1 is still answering. Voyager's original mission, a leap into the unknown. When the Voyager mission was conceived in the early 1970s, it was nothing short of audacious. A daring leap into the unknown. The primary objective was ambitious: to collect detailed data on the 4 giant outer planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, through close-up exploration that had never before been attempted. At that time, these planets remained largely mysterious, distant orbs observed only through Earth-bound telescopes. Their complex systems of moons, magnetic fields, atmospheres, and potential ring structures were shrouded in uncertainty. Voyager was designed to change that forever. The mission sought to pull back the cosmic curtain, sending back high-resolution images and scientific measurements that would unravel the secrets of these colossal worlds. From the swirling storms of Jupiter to the elegant rings of Saturn, from the icy blue expanse of Uranus to the deep azure hues of Neptune, the Voyager spacecraft promised to deliver a view of the outer solar system unlike anything humanity had ever seen. But despite the excitement, skepticism loomed large. Many questioned whether the spacecraft could even survive the launch, let alone withstand the immense distances and harsh conditions of deep space. These concerns were far from unfounded. After all, no mission had ever attempted such an extensive voyage through the outer solar system. The journey would take years. The technology was untested on such a scale, and there were no guarantees of success. Fuel limitations, signal delays, mechanical failures. Any number of problems could have ended the mission prematurely. And yet, the team pressed on. Against the odds, Voyager 1 and its twin, Voyager 2, not only survived, they thrived. They conducted flawless flybys of the target planets, capturing images that astonished the world and collecting data that transformed planetary science. Thanks to Voyager, we discovered active volcanoes on Jupiter's moon Io, observed complex weather systems on Neptune, mapped intricate magnetic fields, and even detected unexpected ring systems around planets like Uranus. What was once theory became fact. What was once invisible became breathtakingly real. In hindsight, what seemed like a gamble turned into one of the greatest scientific triumphs in human history. And remarkably, the mission didn't end with the outer planets. Voyager's story was just beginning. Propelled by its own momentum, Voyager 1 journeyed on, setting its course for the stars. Today, it continues its odyssey in interstellar space, carrying with it a golden record, a message from Earth, a time capsule for any distant intelligence that might one day discover it. Voyager's triumph, a legacy of ingenuity and discovery. However, against all expectations and despite immense technical hurdles, the Voyager spacecraft defied all odds, embarking on an extraordinary odyssey of scientific exploration, an odyssey that continues to shape our understanding of the cosmos even to this day. Launched in 1977, Voyager 1 and Voyager 2 were more than just spacecraft. They were symbols of human ingenuity, resilience, and an insatiable thirst for discovery. At a time when direct data on the outer planets was scarce and only a handful of missions had ventured beyond Mars, Voyager dared to do the impossible. It pushed the boundaries of our planetary knowledge, becoming the first mission to provide close-up images and in-depth data on Jupiter, Saturn, Uranus, and Neptune, forever transforming how we understand the gas and ice giants that inhabit the outer reaches of our solar system. Engineers and scientists faced enormous challenges. With no precedent for such a long and complex journey, obtaining precise measurements of distant planets, their atmospheres, rings, and moons was a formidable task. The vacuum of space, intense radiation belts, signal delays across billions of kilometers, these were just a few of the formidable obstacles the mission had to overcome. And yet, Voyager was ready. Both spacecraft were equipped with a suite of 11 advanced scientific instruments, each meticulously designed to capture different aspects of the planets and their environments. These included imaging systems for capturing detailed photographs of planets, moons, and ring systems, infrared and ultraviolet spectrometers to analyze atmospheric composition and thermal radiation, magnetometers to measure magnetic fields, cosmic ray and plasma detectors to study solar wind and interstellar particles, photopolarimeters and radio science instruments to probe planetary densities and structures. With these tools, Voyager did far more than anyone expected. It discovered volcanoes erupting on Io, detected complex ring structures around all 4 outer planets, revealed the dynamic, storm-filled atmospheres of gas giants. The data returned by Voyager laid the groundwork for every outer solar system mission that followed, from Galileo and Cassini to Juno and beyond. More importantly, it ignited the public imagination, demonstrating that we are capable of reaching out across the vast emptiness of space, not just to see, but to understand. Voyager didn't just travel far, it changed everything we thought we knew about the outer solar system. Engineering the impossible, how Voyager defied the darkness of deep space. At the heart of the Voyager missions lies a symphony of sophisticated engineering and scientific ambition. Each probe, Voyager 1 and Voyager 2, was equipped with a suite of highly specialized instruments designed to explore the farthest frontiers of our solar system. These included photometers, magnetometers, cameras, charged particle detectors, radio antennas, and plasma detectors, each playing a crucial role in analyzing planetary environments, magnetic fields, radiation belts, and distant atmospheric phenomena. Yet, deploying this technology posed a monumental challenge. Operating sensitive instruments billions of kilometers away from the Sun in the cold, silent void of deep space was an unprecedented task. Unlike missions closer to Earth, Voyager could not rely on solar panels for energy, as the Sun's light was too faint to be of any practical use. To overcome this hurdle, NASA engineers turned to nuclear energy, harnessing the power of radioisotope thermoelectric generators, RTGs, a brilliant solution that would become the backbone of Voyager's longevity. Each spacecraft carried plutonium-238, a radioactive material whose natural decay produces heat. The RTGs ingeniously converted this heat into electricity, ensuring a steady, reliable power source that would function regardless of the spacecraft's distance from the Sun or the passing of decades. These compact power plants enabled Voyager's systems to remain operational even as they traversed the frozen frontiers of space, where temperatures plummet to hundreds of degrees below zero and sunlight is a distant memory. Each Voyager spacecraft carried approximately 722 kilograms of payload, comprising scientific instruments, communication systems, and power sources, all meticulously arranged to withstand the harsh rigors of space travel. The probes had to operate with extreme autonomy, capable of managing critical functions and making real-time decisions based on pre-programmed algorithms due to the immense communication delay with Earth. Thanks to this visionary engineering, the Voyager twins have transmitted invaluable data for over 4 decades. They have rewritten textbooks, uncovered new planetary phenomena, and extended the reach of human understanding into the interstellar medium, a realm no spacecraft had ever entered before. The story of Voyager is not only a triumph of science, but also a resounding testament to human creativity, problem-solving, and our determination to seek knowledge, no matter how distant the destination may be. Strategic precision: how NASA engineered the grand tour of the outer planets. Sending a spacecraft into the vast and unforgiving expanse of our solar system is no small feat, especially in the 1970s, when spaceflight technology was still in its relative infancy. The Voyager missions required not only remarkable engineering and endurance, but also strategic genius to ensure their success. One of the key challenges was power management. For the spacecraft to function efficiently and avoid aimless drifting through space, they required substantial and uninterrupted power. A task that NASA solved with the use of radioisotope thermoelectric generators. But generating power was only part of the equation. Planning the journey itself demanded equal brilliance. NASA's engineers meticulously charted the mission trajectories, utilizing an ingenious technique known as gravity assist, a maneuver in which a spacecraft uses the gravity of a planet to gain speed and alter its course. By harnessing the gravitational pull of Jupiter and Saturn, the Voyagers could be slingshotted farther into the solar system without expending extra fuel. allowing them to travel vast distances with remarkable efficiency. The timing of the mission was critical. In the late 1970s, the outer planets Jupiter, Saturn, Uranus, and Neptune were entering a rare, favorable alignment that occurs only once every 176 years. This unique positioning allowed for what NASA called the Grand Tour, a chance to visit all 4 giant planets in a single mission, using consecutive gravity assists to propel the spacecraft from one planet to the next. Initially, NASA envisioned a single ambitious spacecraft to complete this entire tour. However, due to budgetary constraints and technical risks, the agency opted for a more cost-effective and flexible solution, launching 2 identical spacecraft, each with its own specific trajectory and mission goals. Thus, Voyager 1 and Voyager 2 were born. Voyager 1 was designated to fly by Jupiter and Saturn, getting close enough to study their atmospheres, moons, and rings in unprecedented detail. Voyager 2, meanwhile, was tasked with exploring all 4 outer planets, Jupiter, Saturn, Uranus, and Neptune, becoming the only spacecraft in history to have visited all of them. Despite the limitations of 1970s technology, no GPS, no onboard AI, and minimal computer memory, NASA's planning left no stone unturned. Every trajectory calculation, communication schedule, and instrument command had to be programmed in advance with precision and foresight. There was no room for error in the dark and distant void. Against all odds, the Voyager mission persevered. What started as a bold idea evolved into one of the most iconic and enduring achievements in the history of space exploration. These spacecraft not only survived the journey, but also exceeded every expectation, becoming the longest operating and farthest traveling spacecraft humanity has ever launched. Voyager 1's encounter with Jupiter, a turning point in planetary science. When NASA launched the Voyager spacecraft, it did so with high hopes and bold ambitions, but much of what the mission might reveal remained rooted in optimistic speculation. At the time, the outer planets were enigmatic giants, their moons little more than distant, blurry dots captured in telescopic glimpses from Earth. Yet the Voyager mission pressed forward, determined to overcome the uncertainties and break through the boundaries of human understanding. In 1979, Voyager 1 reached Jupiter, the largest planet in our solar system. What unfolded during this flyby marked a historic turning point in planetary science. Among the many stunning revelations, one in particular captured the imagination of scientists around the globe. Jupiter's moon, Io, long thought to be just another rocky satellite, was found to be geologically active. This was a revolutionary discovery. Up to that point, Earth had been considered the only body in the solar system with active geology, volcanoes, tectonic movements, and internal heat flow. Io, smaller than Earth's moon and just a third the size of Earth, defied all expectations. Voyager 1 captured astonishing images of Io's surface, erupting volcanoes, shifting terrain, and widespread lava flows, revealing that this tiny moon was the most geologically active object in the entire solar system. Even more remarkable was the intensity of Io's activity. Despite its modest size, Io was generating twice as much internal heat as Earth. This immense energy output wasn't due to radioactive decay or solar heating, but rather the result of tidal heating, a process driven by the gravitational tug-of-war between Jupiter and its neighboring moons, Europa and Ganymede. As Io orbited the gas giant, it experienced constant flexing, causing its interior to heat up dramatically and fuel continuous volcanic eruptions. The surface of Io, unlike anything seen before, was a vibrant mosaic of sulphurous plains, towering plumes, and lava lakes, with colors ranging from yellow and orange to red and black. Some volcanic plumes were found to erupt hundreds of kilometers into space, a spectacle that redefined scientists' understanding of how dynamic a moon's surface could be. This discovery alone would have been enough to cement the success of the Voyager program, but it was only the beginning. Voyager 1's findings at Jupiter, and particularly at Io, reshaped planetary science. It proved that geologic activity was not limited to Earth, opening the door to new theories about potential habitability on other moons, such as Europa, and later Enceladus and Titan. Voyager 1's flyby of Jupiter was more than a mission milestone. It was a moment that changed the way we look at the solar system. It reminded us that even the most unassuming celestial bodies could hold astonishing surprises, and it underscored the value of exploration, venturing into the unknown, driven by curiosity, only to discover realities far more wondrous than imagined. Voyager 1's discoveries at Jupiter, redefining planetary science. The Voyager 1 mission's close encounter with Jupiter didn't just provide breathtaking visuals of the largest planet in our solar system. It shattered long-held assumptions and revolutionized our understanding of gas giants and their complex systems. Among its most surprising revelations was the geologic dynamism of Io. But that was just the beginning. As Voyager 1 continued its flyby, it unveiled a tapestry of scientific findings that would forever change how we study the cosmos. One of the most unexpected discoveries was the enormity and strength of Jupiter's magnetosphere, the magnetic field that surrounds the planet. Previously, scientists had underestimated its scale, but Voyager 1 revealed that Jupiter's magnetosphere is the largest structure in the solar system, stretching outward until it nearly reached the orbit of Saturn, a distance of over 10 million kilometers. This discovery emphasized just how powerful Jupiter's magnetic influence is, affecting not only its own moons and rings, but also the solar wind far beyond what anyone had predicted. The probe's suite of instruments also penetrated the secrets of Jupiter's atmosphere. It analyzed the planet's composition in unprecedented detail, detecting a mix of hydrogen and helium, the primary elements as expected, but also traces of water vapor, methane, ammonia, and even rocky materials. These findings provided scientists with valuable clues about Jupiter's internal structure, formation history, and the dynamic processes taking place in its turbulent clouds. Through high-resolution imaging and data collection, Voyager 1 captured images of Jupiter's Great Red Spot, a massive storm that had already raged for centuries, and unveiled swirling cloud bands, chaotic atmospheric motions, and fast-moving jet streams. The planet's ever-changing weather systems, driven by internal heat and rapid rotation, painted a vivid picture of a world alive with activity, despite having no solid surface. Even more astonishing was what Voyager uncovered about Jupiter's moons. Not only Io, but Europa, Ganymede, and Callisto. Each of these Galilean satellites showed unique characteristics, from cracked icy surfaces to evidence of internal oceans, hinting at the possibility of subsurface water and even conditions suitable for life in the most unexpected places. These findings collectively expanded the scientific paradigm. Before Voyager 1, moons were often thought of as cold, inactive bodies, mere rocks orbiting planets. But now, they were seen as diverse and complex worlds, some with active volcanoes, hidden oceans, or mysterious terrain, each deserving of further exploration. Voyager 1's mission to Jupiter served as a powerful reminder. The solar system is far more intricate and alive than previously imagined. What started as a mission to collect data transformed into a voyage of revelation, deepening our understanding of planetary geology, atmospheric dynamics, and magnetic fields on a grand scale. This historic flyby didn't just enrich our scientific libraries, it sparked new questions and laid the foundation for future missions. It also inspired a generation of astronomers, engineers, and explorers to continue humanity's relentless pursuit of knowledge beyond Earth. Voyager's unprecedented discoveries, from Jupiter to Saturn. As Voyager 1 departed the realm of Jupiter, it left behind a treasure trove of discoveries that redefined planetary science. Yet, its journey was far from over. With unwavering precision, the spacecraft set its course for Saturn, the sixth planet from the Sun, and another celestial giant cloaked in mystery. But before we plunge into the wonders of Saturn, it's important to reflect on one final, critical chapter from Voyager's exploration of Jupiter: the unexpected discoveries surrounding its rings and moons. In a stunning revelation, Voyager 1 captured the first up-close image of a narrow, dark ring encircling Jupiter. A phenomenon that had eluded astronomers for decades. The ring's existence, previously undetected from Earth, was believed to be composed of fine dust particles, and possibly the remnants of an ancient moon pulverized by past collisions. This finding challenged assumptions that only Saturn possessed rings and opened a new frontier of inquiry into the dynamics of planetary ring systems. Additionally, Ganymede, Jupiter's largest moon and the largest in the entire solar system, came under intense scrutiny. Voyager 1's sophisticated instruments detected the presence of a tenuous atmosphere, an exosphere composed mostly of oxygen. This was a groundbreaking discovery. Up until then, Ganymede was considered geologically dead and atmosphereless. The existence of this thin atmosphere suggested internal activity and set the stage for later missions, such as the upcoming ESA's Jupiter Icy Moons Explorer, USH, and NASA's Europa Clipper. Together, these findings reshaped our understanding of Jupiter as not just a giant gaseous planet, but a complex system teeming with dynamic moons, active geology, hidden atmospheres, and mysterious rings. It was a microcosm of cosmic diversity, waiting to be studied for generations. Voyager 1, at Saturn, unveiling the secrets of the ringed giant. With its instruments still functioning optimally, Voyager 1 journeyed farther into the outer solar system, setting its sights on Saturn. Arriving in 1980, it encountered a world unlike any seen before, an ethereal planet adorned with breathtaking rings and home to one of the most intriguing moons in the solar system, Titan. Perhaps the most astonishing revelation of this leg of the mission was related to Titan, Saturn's largest moon. As Voyager 1 flew past it, scientists were astounded to discover that Titan's solid core had a smaller diameter than Ganymede, despite Titan being shrouded in a thick atmosphere that made it appear larger from afar. This challenged previously held beliefs and prompted a re-evaluation of how moons formed and evolved. The probe also revealed that Titan's dense atmosphere was primarily composed of nitrogen, with traces of methane and complex hydrocarbons, an atmospheric makeup strikingly similar to that of early Earth. Although Voyager 1 was unable to see Titan's surface due to the thick orange haze, It provided strong evidence that liquid lakes or seas could exist beneath the clouds, paving the way for future missions like Cassini-Huygens, which later confirmed the existence of methane lakes. Moreover, Voyager 1's approach offered unprecedented views of Saturn's rings. What once seemed like uniform bands through telescopes were now revealed to be composed of thousands of smaller ringlets, each a delicate structure of ice and rock particles, ranging from microscopic grains to large boulders. The rings displayed intricate wave patterns caused by the gravitational influence of Saturn's moons, adding yet another layer of complexity to the planet's environment. The spacecraft also identified several previously unknown moons orbiting Saturn and revealed intricate magnetic and radiation belts that hinted at dynamic processes happening deep within the gas giant's core. A legacy of discovery. The discoveries made by Voyager 1 at Jupiter and Saturn were more than just data points. They were revelations that forever altered our perception of the solar system. Each encounter unveiled phenomena that defied expectations, challenged theories, and inspired countless new questions. By capturing stunning visuals, analyzing complex atmospheric compositions, uncovering geologic activity, and mapping planetary magnetospheres, Voyager 1 expanded the frontier of human knowledge. Its journey stands not only as a testament to human ingenuity and curiosity, but as a gateway to understanding our place in the vast cosmos. And yet, the Voyager story doesn't end at Saturn. As the probe moved beyond the gravitational grip of our major planets, it ventured into a new and uncharted domain, interstellar space. Becoming the first human-made object to do so, the Voyager missions unveiled the magnificent moons of Saturn in unprecedented ways, providing invaluable data that continues to fuel scientific research decades later. These missions stand as a towering testament to human ingenuity and the unquenchable thirst for exploration and discovery. Voyager's meticulous exploration of Saturn marked a significant milestone, unearthing astonishing findings about our nearest gas giant neighbor. Despite Saturn being one of the most studied planets in our solar system, the mission revealed that even worlds we think we understand can still harbor unexpected surprises. These discoveries remind us that close, detailed examination often uncovers hidden complexities that reshape our understanding. While the Voyager probes gathered a wealth of information during their initial flybys, their journey did not end there. As they continued on their path toward interstellar space, the probes presented scientists with a unique opportunity to delve even deeper into the nature of these planets and their surroundings. Through detailed investigations, the Voyager spacecraft revealed new phenomena, expanding our knowledge far beyond what was previously imagined and setting the stage for future exploration of the outer solar system. With meticulous data collection and thorough analysis, the Voyager missions provided scientists with a deeper understanding of Saturn's atmosphere, magnetosphere, rings and moons. The probes uncovered new and intricate features, such as complex ring structures, dynamic storm systems, and previously unknown atmospheric phenomena. These findings dramatically expanded our comprehension of this gas giant, revealing its secrets in ways that had once seemed unimaginable. The wealth of data gathered from Voyager's in-depth studies not only enriched our knowledge of Saturn, but also deepened our broader understanding of the outer solar system. These missions continually fuel human curiosity and the drive for exploration, standing as a powerful testament to human ingenuity and our relentless pursuit of cosmic knowledge. Voyager probes are forever remembered as pioneering endeavors that broadened humanity's horizons and unlocked new mysteries within the universe. In a groundbreaking announcement in February 2023, astronomers revealed an astonishing new discovery. They had identified 12 new moons orbiting Jupiter, bringing the total confirmed number of moons around the gas giant to an unprecedented 92. This remarkable finding highlights that even decades after the Voyager missions, the outer planets continue to surprise and captivate us, offering endless opportunities for discovery. This extraordinary discovery firmly establishes Jupiter as the planet with the highest number of natural satellites in our solar system, surpassing the previous record held by Saturn, which has 83 moons. The dozen newly identified moons were detected and carefully observed using advanced telescopes located in Chile and Hawaii during 2021 and 2022. Following meticulous data collection and rigorous analysis, the discovery was officially confirmed in 2023. This remarkable finding adds significant depth to our ever-growing understanding of the complex and dynamic Jovian system, offering new insights into the intricate gravitational ballet performed by the numerous moons orbiting this massive gas giant. It also highlights the continuous advancements in astronomical observations and reflects humanity's unrelenting curiosity to explore and unravel the mysteries of the cosmos. After their initial detection, the orbits of these new satellites were meticulously tracked and confirmed through extensive follow-up observations conducted by a dedicated team of scientists. This further in-depth analysis has not only validated their existence, but also helped refine our knowledge of their orbital characteristics, stability, and interactions within Jupiter's vast gravitational influence. The discovery of these moons serves as a reminder that despite centuries of astronomical study, our solar system continues to hold surprises, and each new revelation brings us closer to understanding the full complexity of the cosmic neighborhood we call home. Further investigations into these newly discovered moons revealed intriguing details about their characteristics. Ranging in size from 1 to 3 kilometers, these moons were identified as regular satellites exhibiting retrograde motion, meaning they orbit Jupiter in a backward direction, opposite to the planet's rotation. This unusual orbital behavior highlights the complex gravitational interactions shaping the Jovian system. Moreover, astronomers determined that the moons display a diverse range of orbital periods. Some take several years to complete a single orbit, while others complete their journeys in just a few months before repeating the cycle. This variation showcases the dynamic and intricate motions of these celestial bodies within Jupiter's vast gravitational sphere. These recent discoveries offer compelling new evidence supporting the pioneering observations made during the Voyager mission of 1979. That historic mission had hinted at the existence of a significant population of moons around Jupiter, and now, with the addition of these newly confirmed satellites, astronomers possess even more robust data to confirm Jupiter's remarkable abundance of natural moons. Such findings underscore the continuous progress in our understanding of the Jovian system and provide valuable insight into the complex dynamics governing the interactions among Jupiter's moons. They fuel our scientific curiosity and deepen our appreciation for the wonders of the universe, reminding us that despite decades of exploration, the cosmos still holds countless mysteries waiting to be uncovered. In the coming months and years, several ambitious space missions by leading space agencies are poised to deepen humanity's understanding of Jupiter and its intriguing moons, ushering in a new era of planetary exploration. Among these, the European Space Agency, ESA, has set its sights on launching a sophisticated spacecraft in April 2023. This mission is designed to study Jupiter and its diverse icy moons with enhanced precision and advanced instrumentation, aiming to unravel the mysteries that surround these distant celestial bodies. The spacecraft will focus on gathering comprehensive data about the planet's atmosphere, magnetosphere, and the unique geophysical features of its moons. Simultaneously, NASA is preparing to launch its highly anticipated Europa Clipper mission, slated for the near future. This mission targets Europa, one of Jupiter's most enigmatic moons, long suspected to conceal a vast, potentially life-supporting ocean beneath its thick icy crust. The Europa Clipper aimed to perform detailed reconnaissance of the moon's surface and subsurface, analyzing its ice shell, ocean depth and composition, as well as identifying possible locations where life could exist. By probing the ice shell's fractures and geysers, the mission seeks to better understand Europa's habitability and assess its potential to support microbial or even more complex life forms. These forthcoming missions promise to deliver an unprecedented wealth of data and insights, fundamentally enriching our comprehension of the Jovian system and advancing the broader quest to understand the conditions necessary for life beyond Earth. The discoveries made by these spacecraft will not only expand our knowledge of Jupiter and its moons, but will also shed light on planetary formation, geological processes, and the dynamics of icy worlds throughout the solar system. Breakthroughs in studying gas giants like Jupiter and Saturn have, in recent decades, opened up entirely new mysteries and avenues for exploration. These planets are not just distant giant worlds. They are dynamic environments with complex weather systems, powerful magnetic fields, and a rich collection of moons, many of which may be ocean worlds. Understanding these systems can provide key insights into the early history of the solar system and the potential for life in environments vastly different from Earth. Looking to the future, advances in space travel technology such as theoretical developments in light speed or near-light speed propulsion may one day allow astronauts to visit the surfaces of these gas giants or their moons directly. While such technology remains speculative and faces significant engineering and physical challenges, it embodies humanity's relentless drive to push boundaries and expand the frontiers of exploration. Visiting Jupiter's and Saturn's moons in person would revolutionize planetary science by enabling direct sampling, detailed surface studies, and on-the-spot investigations of their atmospheres and geophysical characteristics. As we continue this unfolding journey to uncover the secrets of our solar system and beyond, the role of these upcoming missions cannot be overstated. They represent humanity's insatiable curiosity and unwavering commitment to exploring the cosmos, reminding us that despite centuries of study, the universe remains a vast frontier filled with boundless wonders and unanswered questions. We encourage all space enthusiasts and curious minds to stay tuned for updates from these groundbreaking missions, follow the latest discoveries, and share their thoughts and excitement about the future of space exploration. Together, we partake in an unending voyage towards unlocking the secrets of the cosmos, a journey that promises to transform our understanding of the universe and our place within it. The wonders of space exploration truly are boundless, and each new mission brings us closer to grasping the full majesty and mystery of the heavens above. In the vast, ever-expanding frontier of human exploration, there exists a journey so awe-inspiring and monumental that it transcends the very boundaries of time and space. This epic voyage is none other than the extraordinary odyssey of Voyager 1, a pioneering spacecraft launched by NASA that has traveled farther than any other human-made object, carrying the hopes and dreams of humanity into the deepest reaches of the cosmos. Recently, Voyager 1 sent back a historic transmission to Earth that has ignited waves of excitement and curiosity throughout the global scientific community and beyond. At the heart of this remarkable message lies a discovery of unparalleled significance, an enigmatic object detected in the profound, uncharted depths of interstellar space. This mysterious revelation has reignited one of the most timeless and compelling questions that has captivated humanity for generations. Could this signal represent the long-awaited moment when we finally establish contact with advanced extraterrestrial life? For centuries, humankind has gazed up at the night sky with wonder, imagining the possibility of other civilizations thriving among the stars. Now, this revelation has brought those age-old dreams tantalizingly close to reality. Voyager 1's journey began decades ago when it was launched on September 5, 1977, as part of NASA's ambitious Voyager program. Its mission was bold and profound: to act as Earth's emissary, venturing beyond the familiar realms of our solar system into the vast unknown. While meticulously studying the outer planets and their moons, Voyager 1's remarkable voyage was marked by a serendipitous cosmic alignment. It set off just 16 days before its twin, Voyager 2, beginning a cosmic ballet that has unfolded for more than 40 years. What truly sets Voyager 1 apart from countless other space missions is its extraordinary spirit of communication. Despite its unfathomable distance from Earth, Voyager 1 maintains a steadfast dialogue with our home planet through NASA's venerable deep space network. This complex and powerful communication system allows Voyager 1 not only to receive commands, but also to transmit back invaluable streams of scientific data, bringing us ever closer to understanding the cosmos. As of the latest measurements, Voyager 1 is an astonishing 159.32 astronomical units AU away from Earth, equivalent to nearly 23.8 billion kilometers, or approximately 14.8 billion miles. This staggering distance makes it the most distant human-made object ever to voyage into space. Yet, despite this incredible remoteness, Voyager 1's instruments continue to operate, tirelessly collecting and sending back information that deepens our understanding of the universe around us. Voyager 1's primary mission was to explore the outer boundaries of the heliosphere, the vast bubble of charged particles and magnetic fields generated by the Sun. This outer boundary, called the heliopause, marks the frontier where the influence of our star gives way to the cosmic environment of interstellar space. Crossing this threshold in 2012, Voyager 1 became the first human-made object to enter the space between stars, beginning a new chapter in space exploration. What makes Voyager 1's mission truly remarkable is not only its groundbreaking discoveries, but also its extraordinary endurance. Originally designed to last only a few years, Voyager 1 has surpassed all expectations, continuing its interstellar journey for over 4 decades. Each day, it cruises through the void at an incredible speed of approximately 38,000 miles per hour, sending precious data back to Earth across billions of miles. Scientists anticipate that Voyager 1 will continue this historic mission at least until 2025, when its power sources are expected to diminish. Equipped with a sophisticated suite of 10 scientific instruments, including cameras, infrared and ultraviolet sensors, magnetometers, plasma detectors, cosmic ray sensors, and radio science equipment, Voyager 1 was built to be humanity's eyes and ears in the cosmos. These instruments have enabled the spacecraft to withstand the harsh and unforgiving conditions of deep space, while delivering an unprecedented wealth of knowledge about the outer solar system and beyond. Among Voyager 1's most celebrated achievements are its close flybys of two colossal gas giants, Jupiter and Saturn. In 1979, Voyager 1 made its first close approach to Jupiter, revealing breathtaking details about the planet's turbulent atmosphere, intricate ring system, and diverse moons. The spacecraft's instruments confirmed the existence of faint rings around Jupiter, previously only theorized, and uncovered previously unknown moons that added to our understanding of the planet's complex environment. A year later, in 1980, Voyager 1's encounter with Saturn provided equally stunning insights. It unveiled the intricate structure of Saturn's iconic rings, captured detailed images of its moons, and deepened our knowledge of the planet's magnetic field and atmosphere. These flybys not only revolutionized planetary science, but also inspired a new generation of explorers, scientists, and dreamers around the world. One of the most iconic moments in Voyager 1's journey came in 1990, when the spacecraft, prompted by the visionary astronomer Carl Sagan, turned its cameras back toward Earth and captured the now famous image known as the pale blue dot. In this extraordinary photograph, Earth appears as a tiny speck suspended in a vast cosmic ocean, a fragile and precious home floating in the immense void of space. This image remains a powerful symbol of humanity's shared vulnerability and interconnectedness, reminding us of the urgent need to cherish and protect our only home. As Voyager 1 continues its silent journey through the darkness beyond our solar system, it carries with it the legacy of human curiosity, ingenuity, and the unquenchable desire to explore. Its latest discovery in the depths of interstellar space hints at new cosmic mysteries waiting to be unveiled, perhaps even the momentous encounter with other life forms that so many have dreamed about. This odyssey, which began over 4 decades ago, continues to inspire and challenge us, inviting us all to look up, wonder, and reach ever further into the vast expanse of the universe. Voyager 1 was designed to push the boundaries of human knowledge, traversing vast distances where no spacecraft had dared to go before. Equipped with a suite of sophisticated scientific instruments, it was tasked with studying the giant planets and their moons, capturing unprecedented data that would forever change our understanding of the solar system. What makes Voyager 1 truly extraordinary is not just its groundbreaking discoveries, but its resilience and longevity. Despite being launched over 4 decades ago, it continues to send invaluable information back to Earth, maintaining a lifeline of communication through NASA's Deep Space Network. This unwavering connection allows scientists to receive data from more than 14 billion miles away, a testament to human ingenuity and determination. As Voyager 1 journeys beyond the heliosphere, the protective bubble created by the sun's solar wind, it enters interstellar space, a vast expanse filled with cosmic mysteries. Recently, a signal from Voyager 1 revealed the detection of an enigmatic object lurking in this farthest frontier. This revelation has sent shockwaves through the scientific community and reignited a question that has fascinated humanity for generations. Are we alone in the universe? The possibility that this mysterious detection could be evidence of advanced extraterrestrial life has captivated imaginations worldwide, inspiring scientists, philosophers, and dreamers alike to ponder the cosmic significance of this discovery. As we delve deeper into Voyager 1's findings, we are reminded of the boundless curiosity that drives human exploration, our relentless quest to understand not only the universe, but our place within it. In this unfolding cosmic saga, Voyager 1 stands as a symbol of hope, perseverance, and the unquenchable thirst for knowledge. Its voyage is not merely a scientific endeavor, but a profound journey that connects us all, uniting humanity in awe of the infinite cosmos that stretches beyond our wildest dreams. An intriguing aspect of the Voyager mission narrative lies in the remarkable timing. Voyager 1 began its epic journey just 16 days ahead of its cosmic twin, Voyager 2. This serendipitous alignment lends a sense of cosmic symmetry to an unparalleled saga. Two intrepid emissaries of humanity, launched in close succession, each destined to explore the uncharted realms of our solar system and beyond. What truly distinguishes Voyager 1 from countless other space missions is its indomitable spirit of communication, a lifeline that it maintains steadfastly with Earth across unimaginable distances. This extraordinary feat is made possible by NASA's venerable Deep Space Network, a robust and sophisticated communication infrastructure designed to ensure a constant dialogue between the spacecraft and its home planet. This unyielding link serves a dual purpose. It allows Voyager 1 to receive precise commands from mission control and, in return, to transmit a treasure trove of invaluable scientific data back to its terrestrial origins. According to the most recent data, Voyager 1 currently finds itself at an astonishing distance of approximately 159.32 astronomical units AU from Earth. To put this monumental achievement into perspective, this distance translates to an awe-inspiring 23.834 billion kilometers, or roughly 14.8 billion miles, away from the cradle of humanity. In other words, Voyager 1 is now the most distant human-made object in existence, a lone traveler venturing farther into the cosmic ocean than any other craft before it. This staggering remoteness not only speaks to the spacecraft's incredible durability and the brilliance of human engineering, but also marks a milestone in our quest to understand the universe around us. It is this incomprehensible remoteness that firmly establishes Voyager 1 as the most distant human-made object ever to embark on an odyssey into the vast cosmos. From the moment of its launch, Voyager 1's primary mission objective was clear and profoundly ambitious: to explore and meticulously scrutinize the boundaries of the outer heliosphere, a mysterious and barely understood region known as the heliopause. This invisible boundary marks the outermost layer of the Sun's influence, the final frontier where the solar wind meets the vast interstellar medium, enveloping our entire solar system in a protective bubble. Through its relentless investigations, Voyager 1 has bestowed humanity with invaluable insights into the cosmos, especially within the confines of our immediate solar neighborhood. Propelled forward at an astonishing velocity of approximately 38,000 miles per hour, an incredible speed that allows it to traverse vast cosmic expanses day by day, the spacecraft continues to push the boundaries of exploration and knowledge. Yet, what truly sets Voyager 1 apart is not just its distance or speed, but its remarkable endurance. The spacecraft has not merely met expectations, it has far exceeded its originally projected lifespan. More than 4 decades after its historic launch, Voyager 1 remains operational, tirelessly sending back vital data from the farthest reaches of space. Its ongoing mission serves as a testament to human ingenuity, perseverance, and an insatiable desire to understand the universe around us. Voyager 1 has embarked on extraordinary decades of exploration, defying the limits of time and technology. Each passing day, this remarkable spacecraft dutifully records and transmits vital information about its celestial journey, offering humanity a continuous stream of priceless data from the edge of our solar system and beyond. Remarkably, Voyager 1 is expected to continue this awe-inspiring interstellar sojourn until at least the year 2025, a testament to its resilient propulsion systems and enduring power supply that have kept it operational far beyond initial expectations. By that time, it is estimated that Voyager 1 will have achieved an almost inconceivable distance of approximately 13.8 billion miles from the nurturing embrace of the Sun, a staggering measure of its pioneering voyage into the cosmic unknown. Accompanying Voyager 1 on this grand adventure is its celestial sibling, Voyager 2, both launched as part of NASA's legendary Voyager program. Together, they were equipped with a formidable array of 10 unique scientific instruments, each serving as sensory extensions of the spacecraft into the vast cosmos. This sophisticated ensemble of tools included television cameras, infrared and ultraviolet sensors, magnetometers, plasma detectors, cosmic ray and charged particle sensors, as well as state-of-the-art radio equipment, all meticulously designed to conduct groundbreaking experiments. These ingenious instruments have endowed Voyager 1 with the resilience and capability to withstand the harsh and unforgiving environs of deep space, allowing it to probe the unfathomable reaches of the unknown. One of the most indelible milestones in Voyager 1's storied journey was its close encounters with two of the most majestic and enigmatic bodies in our solar system, Jupiter and Saturn. These historic flybys provided humanity with an unprecedented window into the complexities and wonders of these gas giants, forever reshaping our understanding of the planetary giants and their moons. Voyager 1's encounters with the solar system's colossal planets, Jupiter and Saturn, were nothing short of historic. These celestial rendezvous, which occurred in 1979 and 1980, respectively, marked a watershed moment in the annals of scientific discovery. Through these close flybys, Voyager 1 gifted humanity with an unprecedented glimpse into the intricate complexities of these gas giants and their enigmatic retinues of moons. The spacecraft etched its name indelibly into history by uncovering previously unknown moons orbiting these planets, and by revealing the intricate and delicate ring structures that encircled both Jupiter and Saturn. Prior to Voyager 1's mission, much of this was speculation or incomplete knowledge. Its groundbreaking revelations not only captivated the scientific community, but also ignited the imaginations of people across the globe, heralding a new era of planetary exploration. One of Voyager 1's most iconic and enduring contributions to our cosmic understanding came in 1990, when the celebrated astronomer Carl Sagan championed a visionary concept. He urged the spacecraft to pivot its cameras and direct its lens back towards Earth. This simple yet profound act resulted in the creation of the now famous image known as the pale blue dot. The resulting image, now deeply etched into the collective consciousness of humanity, depicts Earth as a minuscule pale blue dot suspended in the vast cosmic ocean. This poignant image serves as a humbling reminder of the fragility and interconnectedness of our planet, underscoring the imperative to cherish and protect our world. A message that continues to resonate powerfully with people around the globe. Voyager 1's epic journey through the cosmos led it to encounter two of the most enigmatic and majestic celestial bodies in our solar system, Jupiter and Saturn. These monumental encounters provided a treasure trove of scientific data and imagery, fundamentally reshaping our understanding of these gas giants. Jupiter, the largest planet in our solar system, beckoned Voyager 1 with its beguiling mysteries. In March 1979, the spacecraft conducted a close flyby of this colossal giant, granting humanity its first intimate glimpse of the planet's immense scale and complexity. As Voyager 1 ventured closer, it unveiled a tapestry of astounding discoveries. One of the most captivating being the confirmation of Jupiter's intricate ring system. Before Voyager 1's arrival, these faint rings were only a hypothesis, but the spacecraft's keen instruments provided definitive evidence of their existence. Composed of fine, dark particles, these delicate rings encircle Jupiter in an ethereal fashion. The images captured by Voyager 1 offered an entrancing perspective on this subtle feature, captivating the world with their delicate beauty and adding a new dimension to our cosmic knowledge. Another remarkable revelation from Voyager 1's encounter with Jupiter was the unveiling of intricate weather patterns and tempestuous storms on the gas giant's surface. Among these tempests, the most iconic was the Great Red Spot, a colossal storm that has raged for centuries. Voyager 1's imagery of this mammoth tempest not only illuminated the storm's complex structure and dynamic behavior, but also ignited the public's fascination with Jupiter's tumultuous atmosphere. Furthermore, Voyager 1's instruments detected Jupiter's powerful magnetosphere, a colossal magnetic field that dwarfs Earth's own magnetic envelope. This groundbreaking discovery provided crucial insights into the planet's magnetic dynamo and shed light on how this immense magnetic field interacts with its retinue of moons, influencing their environments and contributing to the complex space weather around Jupiter. Following its momentous encounter with Jupiter, Voyager 1 continued its epic odyssey toward Saturn, the majestic ringed planet. In November 1980, the spacecraft made its closest approach to this cosmic wonder, offering humanity an intimate view of Saturn's stunning rings and captivating moons. The detailed images and data collected unveiled previously unseen features of the ring's delicate structure and composition, as well as the diverse geology and atmospheres of Saturn's many moons. One of Voyager 1's most iconic contributions to human perspective came in 1990 with the celebrated pale blue dot image. The esteemed astronomer Carl Sagan championed a visionary idea. He implored the spacecraft to pivot its cameras and turn its lens back toward Earth. This image immortalized our planet as a tiny, fragile speck suspended in the vastness of space, inspiring reflection on our place in the cosmos and a renewed commitment to safeguarding our shared home. The resulting image, now etched deeply into the collective consciousness of humanity, depicts Earth as a minuscule pale blue dot suspended in the vast cosmic ocean. This poignant and humbling image serves as a powerful reminder of the fragility, vulnerability, and profound interconnectedness of our planet within the boundless expanse of the universe. It underscores the urgent imperative to cherish, protect, and preserve our delicate home, a message that continues to resonate with people from all corners of the globe, inspiring reflection on our shared responsibility to safeguard life on Earth. While Voyager 1's extraordinary odyssey primarily focused on the majestic gas giants Jupiter and Saturn, its twin spacecraft, Voyager 2, embarked on a distinct and equally remarkable trajectory. Voyager 2 was destined to explore the enigmatic ice giants of our solar system, Uranus and Neptune, planets shrouded in mystery and complexity, presenting a fresh array of cosmic enigmas for scientists and humanity to unravel. Uranus, the seventh planet from the Sun, is a celestial enigma for many reasons, not least of which is its extraordinary rotation. Unlike any other planet in our solar system, Uranus rotates on its side, with an axial tilt of approximately 98 degrees. This unusual orientation is believed to be the aftermath of a colossal and cataclysmic collision with a massive celestial object in the distant past, which drastically altered the planet's spin. This tilt results in extreme seasonal variations lasting over decades, offering a unique glimpse into planetary dynamics that differ greatly from those of Earth and its planetary neighbors. Despite its unusual tilt and mysterious origins, Uranus remains a captivating and fascinating world. It is approximately 4 times the diameter of Earth and boasts a cold, icy atmosphere composed mainly of hydrogen, helium, and methane, giving it a characteristic blue-green hue. Voyager 2's historic flyby of Uranus in January 1986 marked a momentous milestone in space exploration. For the first time, humanity received detailed images and comprehensive scientific data of this distant ice giant, expanding our knowledge far beyond previous telescopic observations. Among the many groundbreaking discoveries during Voyager 2's encounter was the revelation that Uranus possesses a complex system of rings, a surprising finding since rings were once thought to be unique to Saturn. Voyager 2 revealed that these rings consist of dark, narrow bands composed of tiny particles and debris orbiting the planet, hinting at dynamic processes within Uranus's gravitational influence. In addition to its rings, Voyager 2 discovered 10 new moons orbiting Uranus, each with its own unique characteristics and geological histories. The spacecraft's instruments also provided valuable insights into the planet's atmosphere, uncovering high-speed winds and unexpected temperature variations that challenged existing models of planetary atmospheres. These findings offered a new window into the workings of ice giants, enriching our understanding of planetary formation and behavior in the outer solar system. Voyager 2's journey did not end with Uranus. It continued onward to Neptune, the outermost planet in our solar system, arriving in August 1989. Neptune, with its striking deep blue color and fierce weather systems, presented yet another frontier of exploration and discovery. The data and images sent back by Voyager 2 from Neptune's vicinity revealed powerful storms, supersonic winds, and a moon with active geysers. An astounding discovery that further deepened our appreciation for the dynamic complexity of these distant worlds. Together, the twin Voyager spacecraft have revolutionized our understanding of the solar system's outer realms. Their pioneering missions, spanning more than 4 decades, have transformed once faint and distant dots in the night sky into vividly detailed worlds, full of mystery and wonder. These missions continue to inspire generations of scientists, dreamers, and explorers, reminding us that even at the very edges of human reach, the universe holds countless secrets waiting to be discovered. Voyager 2 revealed a diverse and captivating retinue of moons orbiting Uranus, each possessing unique geological and atmospheric features. Among these, moons like Miranda, Ariel, and Titania stood out, showcasing dramatic landscapes marked by massive canyons, unusual fault lines, and evidence of past geologic activity. These discoveries significantly enriched humanity's understanding of Uranus, shedding light on the complex interactions between the planet and its satellites, and deepening the intrigue surrounding this enigmatic, sideways rotating giant. Voyager 2's interstellar voyage did not end at Uranus. It pressed onward, journeying even farther to reach Neptune, the eighth and most distant known planet from the Sun. Neptune, with its frigid temperatures and vibrant azure hue, remains a haunting symbol of the solar system's outer frontier. This distinct blue coloration is due to the high concentration of methane in its atmosphere, which absorbs red light and reflects the blue. In August 1989, Voyager 2 conducted a historic flyby of Neptune, marking the first, and so far only, close encounter with this distant world. The images and data transmitted back to Earth during this flyby were nothing short of revolutionary. Voyager 2 unveiled a planet with a surprisingly dynamic atmosphere, teeming with violent storms and fierce winds, the fastest sustained winds recorded in the solar system, reaching speeds of over 2,000 kilometers per hour, about 1,200 miles per hour. Among Neptune's most notable atmospheric features was the discovery of the Great Dark Spot, a colossal storm system reminiscent of Jupiter's famous Great Red Spot. However, unlike its Jovian counterpart, the Great Dark Spot proved to be ephemeral. It mysteriously vanished in later observations, raising questions about the atmospheric dynamics of Neptune and the transient nature of its weather system. Perhaps one of the most astonishing revelations from Voyager 2's Neptune encounter was the discovery of the planet's largest moon, Triton, to be an exceptional celestial body that defied expectations. Triton orbits Neptune in a retrograde direction, meaning it moves in the opposite direction of Neptune's rotation. A rare trait that strongly suggests Triton is a captured object, possibly a former Kuiper Belt object that was gravitationally ensnared by Neptune in the distant past. Triton's surface was revealed to be a frozen yet geologically active world, exhibiting nitrogen geysers erupting from beneath its icy crust, a phenomenon never before observed on a celestial body so distant from the Sun. This cryovolcanic activity indicated that Triton, despite its remoteness and frigid temperatures, harbors internal heat and dynamic processes beneath its surface. Voyager 2's images showed a landscape marked by frozen plains, ridges, and sparsely cratered terrain, suggesting a young and possibly evolving surface. These groundbreaking discoveries at Neptune and Triton not only captivated the global scientific community, but also sparked the imaginations of people around the world. The Voyager 2 mission demonstrated the boundless potential of human curiosity and ingenuity, reminding us that even the most remote and mysterious corners of our solar system can be brought into the realm of human understanding. Voyager 2's historic flybys of Uranus and Neptune marked the end of humanity's first grand tour of the outer planets, a monumental chapter in the annals of space exploration. Yet, like its twin Voyager 1, Voyager 2 continues to voyage beyond the known, transmitting faint whispers of data from the edge of interstellar space, ensuring that its legacy endures not just in scientific discovery, but in the shared human spirit of exploration. Triton, the largest moon of Neptune, emerged as one of the most fascinating and enigmatic celestial bodies encountered during Voyager 2's interplanetary odyssey. The spacecraft's imagery revealed a world brimming with activity, despite its remote location and frigid climate. Among Triton's most extraordinary features were geysers that erupted from beneath its icy surface, spewing nitrogen gas high into the moon's thin atmosphere. These geysers created vast plumes that extended kilometers above the surface, where the nitrogen would condense into snow-like particles and gently settle back to the ground, sculpting a surreal and alien landscape of frost and ice. This striking phenomenon was unlike anything previously observed in the solar system, offering profound insights into cryovolcanism, the eruption of volatile substances like water, ammonia or methane, rather than molten rock. Triton's surface, relatively young and sparsely cratered, hinted at a geologically active history, defying expectations for a moon so far from the Sun. Perhaps even more puzzling was Triton's retrograde orbit. It revolves around Neptune in the direction opposite to the planet's rotation. This uncommon trait strongly suggests that Triton did not form alongside Neptune, but was instead a captured object, likely originating from the Kuiper Belt. Its gravitational capture would have disrupted Neptune's original satellite system and left Triton locked in a stable but unusual orbital dance, one that continues to intrigue astronomers to this day. Voyager 2's encounters with Uranus and Neptune remain unparalleled achievements in the history of space exploration. To this day, no other spacecraft has visited these distant ice giants, making Voyager 2's observations and data collection an irreplaceable scientific treasure. The trove of information gathered during these historic flybys continues to fuel research and hypotheses, offering glimpses into the atmospheric dynamics, magnetic fields, ring systems, and unique satellite compositions of these mysterious worlds. While Voyager 2 was delving into the secrets of the outer planets, its twin, Voyager 1, was forging an even more audacious path, a journey that would take it beyond the boundaries of the solar system and into interstellar space. This transition, which occurred in August 2012, marked a profound and historic milestone for humanity. For the first time, a human-made object had crossed the heliopause, the boundary where the solar wind yields to the interstellar medium. Voyager 1's entry into interstellar space did not signify the end of its mission, but rather the beginning of a new chapter. As it continues its voyage through the vast and silent reaches of the cosmos, it carries with it not only scientific instruments, but also a symbolic message from Earth, etched in the form of the Golden Record, a phonograph disc containing sounds, music, and greetings from our planet. Now billions of miles from Earth, Voyager 1 operates in a realm beyond the Sun's influence, where the environment is dominated by particles, fields, and forces that originate from other stars. Its instruments, though fewer in number now, continue to return invaluable data about the nature of interstellar space, helping scientists to understand the shape and boundary of the heliosphere and the conditions in the space between the stars. The enduring journey of the Voyager spacecraft, Voyager 1, venturing outward into the galaxy, and Voyager 2, providing the only close-up views of Uranus and Neptune, remains one of the most ambitious and successful missions in the history of space science. They have not only expanded the boundaries of human knowledge, but have also inspired generations to look upward and dream of what lies beyond, gathered groundbreaking data that challenged earlier assumptions and reshaped our understanding of this mysterious frontier. Rather than a simple comet-like structure with a long tail trailing away from the Sun, Voyager 1's measurements suggested that the heliopause is more complex, possibly a distorted bubble-like shape influenced by both the solar wind from within and interstellar forces from beyond. As Voyager 1 crossed this boundary in 2012, it recorded a sudden and lasting drop in solar particles, while simultaneously detecting a surge in galactic cosmic rays, energetic particles that originate from supernovae and other powerful cosmic phenomena far outside our solar system. This was the smoking gun, clear empirical evidence that the spacecraft had exited the heliosphere and entered the vast ocean of interstellar space. Within this realm, Voyager 1's instruments continued to function, albeit in a limited capacity due to the fading power supply and increasing distance. Even so, its plasma wave subsystem detected a persistent background hum, long, low-frequency vibrations in the plasma of interstellar space. This discovery provided an unprecedented glimpse into the density and behavior of particles between the stars, and demonstrated that the void of space is, in fact, filled with subtle and dynamic forces. Voyager 1's ongoing mission in interstellar space is a testament to both technological resilience and scientific ambition. It represents the first time humans have been able to directly measure the environment of interstellar space, rather than relying solely on telescopes or theoretical models. The data sent back by Voyager 1 continues to challenge assumptions and refine our models of how the Sun interacts with the galaxy around it. As it sails farther into the unknown, Voyager 1 is also pushing the limits of communication. Its faint signals traveling at the speed of light now take over 22 hours to reach Earth. Each byte of data is a time capsule, whispering stories from the edge of the solar system to a waiting world. Despite being over 46 years old, the spacecraft continues to surprise. In recent years, engineers have performed innovative workarounds to keep it operational, including rerouting functions through backup systems. These efforts ensure that even in its twilight years, Voyager 1 remains a pioneer, a silent emissary of Earth, drifting among the stars. Its journey into interstellar space is not just a scientific achievement, but a symbolic one. Voyager 1 carries the golden record, a carefully curated message intended for any intelligent life that might one day encounter it. Engraved with greetings in 55 languages, music from cultures across the Earth, and images depicting life on our planet, the golden record serves as humanity's cosmic calling card, a whisper to the universe saying, "We were here, we reached this far, and we are curious." Voyager 1 is now far beyond the planets, beyond the influence of our star, continuing its voyage in the silence of deep space. It is alone, yet never forgotten. Its legacy etched into history, its mission ongoing, and its story inspiring countless new explorers to reach for the stars. These observations from Voyager 1 provided a transformative understanding of the heliopause and its complex relationship with the galactic environment. Prior to Voyager's journey, much of what scientists knew about the heliosphere was theoretical, based on models, simulations, and indirect evidence. But as Voyager 1 approached and eventually crossed the heliopause, it delivered empirical measurements that revolutionized the field. One of the most unexpected discoveries was the behavior of the magnetic field at the boundary. Scientists had expected a sharp shift in the direction of the magnetic field lines as Voyager 1 transitioned from the Sun's influence to the interstellar medium. However, what they observed was a subtle and unexpected continuity. The magnetic field beyond the heliopods remained aligned in a way that puzzled researchers. This anomaly suggested that the heliosphere might not be as sharply defined or as neatly contained as once imagined. Instead, it could be intertwined or blended with interstellar forces in ways that challenge our understanding of the boundary between solar and galactic domains. These deviations hinted at previously unknown interactions between the solar wind and the interstellar magnetic field, painting a far more dynamic and fluid picture of the Sun's outermost frontier. In addition to its findings on magnetic fields, Voyager 1 also measured plasma density in interstellar space. Unlike within the solar system, where plasma is sparse and influenced by solar activity, the interstellar medium was found to be denser, yet cooler and more stable. This provided critical data that helped astronomers refine their understanding of the material that fills the vast regions between star systems. Voyager 1's traversal into and beyond the heliopause did more than just expand the scientific boundaries of astrophysics. It redefined the scale of our solar system. What was once thought to end at the orbit of Pluto, or perhaps Neptune, was now clearly shown to extend tens of billions of kilometers farther. Enveloped in a vast and shifting magnetic bubble, these findings are not merely academic. They have profound implications for future missions and our long-term aspirations for space travel. Understanding the heliosphere's structure is essential for developing technologies that could one day protect human explorers from cosmic radiation as we venture further from Earth. It also helps in mapping the interstellar environment that any spacecraft, robotic or crewed, would encounter as it journeys to the stars. In essence, Voyager 1's study of the heliosphere turned a once theoretical concept into a tangible and measurable structure, revealing it as a living, breathing force field that protects and defines the domain of our Sun. And while many questions remain about its shape, its interaction with the galaxy, and how it evolves over time, Voyager 1 laid the first real footprints on this invisible frontier. It's a testament to human curiosity and engineering that a spacecraft launched in 1977 continues to inform us decades later about regions of space we had never directly touched before. The mission of Voyager 1 not only broadened our understanding of the heliosphere, but also reminded us that exploration, no matter how distant or difficult, brings us closer to the truth of our place in the cosmos. These contrasting environments encountered by Voyager 1 and Voyager 2 as they crossed the heliopause added profound depth to our understanding of interstellar space. Although both spacecraft pierced the boundary that separates the Sun's protective bubble from the galaxy beyond, the variations in local space weather, magnetic field intensity, and particle density between their paths suggested that interstellar space is not uniform. It is a complex and evolving landscape, shaped by both local and galactic forces. Voyager 2's instruments, still fully operational at the time of its heliopause crossing, recorded direct plasma measurements, something Voyager 1 could not do initially due to a malfunction in its plasma instrument. This allowed Voyager 2 to directly confirm the dramatic rise in plasma density beyond the heliopause, complementing the data Voyager 1 had previously inferred using its cosmic ray and magnetic sensors. This corroboration between two different observational methods provided compelling evidence for a denser interstellar medium just outside our solar system. Moreover, the turbulence Voyager 2 encountered, manifested as fluctuating magnetic fields and wave-like plasma interactions, indicated a more chaotic boundary layer. Scientists hypothesize that this may be due to differences in solar wind pressure or local interstellar cloud structures that distort the heliosphere's edge. In contrast, Voyager 1's path appeared to be through a calmer, more sensitive this frontier is to cosmic condition. Together, these findings from both spacecraft are enabling scientists to create the first three-dimensional models of the heliosphere's outer boundary, which help illustrate its shape, behavior, and interaction with the galaxy. These models are crucial not only for understanding our own solar environment, but also for contextualizing the protective magnetic bubbles that might surround other stars, possibly shielding exoplanets from harmful radiation and influencing their potential to host life. In essence, Voyager 1 and Voyager 2, though launched within weeks of each other, have become dual ambassadors to the galaxy, each offering a distinctive lens on the final frontier of our solar system. Their separate experiences highlight that the edge of our solar system is not a fixed wall, but a living, breathing boundary, shaped by the solar wind's strength, the interstellar medium's density, and galactic magnetic fields that we are only beginning to understand. As Voyager 2 continues its journey through this turbulent interstellar zone, it adds more layers to the grand narrative begun by its twin. Together, they are charting a realm never before visited by humankind. And in doing so, they remind us that even at the edges of our influence, human curiosity and ingenuity still thrive. Reaching out into the unknown, guided by the faint whispers of data traveling billions of kilometers back to Earth, journey marks both a triumph of engineering and a poignant reminder of the finite nature of even our most enduring creations. Now well over 46 years since its launch, Voyager 1 continues to drift deeper into the uncharted sea of interstellar space, carrying with it the legacy of Earth's first true attempt to reach beyond the confines of the Sun's domain. Yet, as the spacecraft travels ever farther, it faces increasing challenges. Its power supply, generated by radioisotope thermoelectric generators, RTGs, is gradually weakening. As of now, NASA engineers have been shutting down non-essential systems to conserve energy and extend the mission's lifespan. Sometime in the late 2020s or early 2030s, Voyager 1 will likely go silent, as its power becomes insufficient to sustain even the low-energy communications that still reach Earth today. Despite this inevitable silence, the spacecraft will not stop traveling. Long after it can no longer send signals or power its instruments, Voyager 1 will continue coasting through the Milky Way galaxy, a silent sentinel bearing the golden record, waiting for a distant intelligence, if such an intelligence exists, to encounter it. This golden record, painstakingly curated by a team led by Carl Sagan, includes readings in 55 languages, music from a wide range of cultures and eras, from Bach and Beethoven to traditional songs from Japan, Senegal, and Peru. Images depicting life on Earth, human anatomy, architecture, DNA structures, and the planet's ecosystems. Sounds of Earth, including the laughter of a child, the roar of the ocean, thunder, and the chirping of birds. These records serve as a kind of cosmic message in a bottle, not with the hope of rescue, but as a declaration: we were here. We reached for the stars. We tried to understand the universe and ourselves. In this way, Voyager 1 and Voyager 2 have transcended their original scientific missions. They have become monuments of human creativity and persistence, testaments to a civilization that dared to send its voice into the dark with no guarantee of reply. They represent an act of faith in the future, a belief that knowledge, wonder, and the desire to explore are enduring parts of what it means to be human. As we gaze toward the heavens, tracking the faint signals from these emissaries, we are reminded that our reach has already extended beyond the solar system, and that even in the cold emptiness of space, our story continues. The Voyager mission teaches us that the journey itself, filled with discovery, wonder, and enduring hope, is as important as the destination. Voyager 1's incredible journey has reignited the world's fascination with this fearless spacecraft. After more than 4 decades of exploration, Voyager 1 has traveled far beyond our solar system, venturing deep into interstellar space. It has crossed the heliopause, the boundary where the sun's influence fades, and now drifts through a vast, uncharted region of the galaxy. In August 2022, Voyager 1 sent a mysterious message back to Earth, one that captured the imagination of scientists and space fans everywhere. Amid streams of data and telemetry, researchers detected a strange anomaly, an object of unknown origin and makeup. Tentatively named the Cosmic Enigma, this object is unlike anything ever encountered in the history of space exploration. What makes the Cosmic Enigma so puzzling? It emits faint, irregular signals that don't match any known natural celestial phenomena. Even more intriguing, its path through space seems deliberate, as if it's following a specific course through the cosmos. This discovery raises deep and fascinating questions. Where did this object come from? Who or what created it? And what might its intentions be? Scientists and astronomers around the world have been meticulously analyzing the data sent by Voyager 1, determined to unlock the secrets of the mysterious cosmic enigma. Could this baffling object be a remnant of an advanced extraterrestrial civilization, or perhaps a probe launched from a distant corner of the galaxy? Alternatively, might it be an entirely new and unknown cosmic phenomenon? The discovery has ignited a wave of speculation and debate, bringing together experts from diverse fields who are collaborating to unravel the enigma's true nature. One leading theory suggests that the cosmic enigma could be an ancient relic from a long-lost civilization, a probe dispatched eons ago, its original mission veiled in the mists of time. Whether its purpose was scientific, exploratory, or something beyond our imagination remains an intriguing mystery. On the other hand, some scientists propose that this object might be a natural celestial phenomenon, with properties that challenge our current understanding of astrophysics. This possibility reminds us of the universe's immense complexity and the vast diversity of cosmic phenomena still waiting to be discovered. It highlights how much we have yet to learn and how little of the universe's secrets we have uncovered. The detection of the cosmic enigma underscores the critical importance of continued space exploration. It calls for humanity to push further into the cosmos, to embrace the unknown, and to expand our cosmic reach. The universe is a vast, mysterious frontier, filled with wonders and enigmas that inspire awe and curiosity. As Voyager 1 continues its solitary voyage through interstellar space, carrying with it the mystery of the cosmic enigma, humanity stands on the brink of new discovery. This spacecraft has become Earth's ambassador to the stars, a shining symbol of our insatiable curiosity and unyielding desire to explore. Voyager 1's odyssey, spanning over 4 decades, has fundamentally reshaped our understanding of the universe. It continues to inspire generations of scientists, dreamers, and stargazers alike. As we ponder the mysteries of the cosmic enigma and the endless possibilities it represents, we are reminded that the cosmos is a vast, wondrous, and ever-evolving realm. Each new discovery brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? With its indomitable spirit and enduring mission, Voyager 1 carries our hopes and dreams as it forges onward into the cosmic unknown. The story of Voyager 1 is a testament to the enduring human spirit of exploration, curiosity, and the relentless quest for knowledge. It transcends time and space, reminding us of our place in the universe and the boundless wonders awaiting us in the cosmic expanse. The enigma. Of the cosmic enigma, serves as a poignant reminder that the universe is filled with mysteries yet to be unraveled. It invites us to continue our cosmic journey with wonder and humility, ever eager to explore the depths of the unknown. Voyager 1, humanity's cosmic emissary, continues to inspire us to reach for the stars and embrace the infinite possibilities that lie beyond. Innovations in science and technology have long been the driving forces propelling economic growth and societal advancement across the globe. Since the dawn of the Industrial Revolution, it has become evident that nations embracing cutting-edge scientific progress and technological breakthroughs invariably position themselves as leaders in development, prosperity, and global influence. This enduring truth continues to shape our modern world, inspiring relentless curiosity and discovery. In a stunning new milestone, the James Webb Space Telescope, a marvel of modern engineering and astronomy, has just revealed an unprecedented, highly detailed image of one of the universe's most iconic structures, the Whirlpool Galaxy. This magnificent cosmic spectacle offers an awe-inspiring display of swirling colors and intricate patterns, illustrating the dynamic and ongoing process of star formation with extraordinary clarity and depth. Scientists and astronomers around the world are abuzz with excitement, as this discovery not only deepens our understanding of galactic evolution, but also opens the door to countless new questions and possibilities. The vivid imagery captured by the Webb telescope allows researchers to peer into the heart of this distant galaxy, studying how stars are born and how vast clouds of gas and dust interact in the cosmic dance of creation. As the scientific community eagerly delves into this treasure trove of data, anticipation builds for the future breakthroughs that this remarkable telescope will bring. The James Webb Space Telescope is not merely a tool for observation. It represents humanity's unyielding quest to unravel the mysteries of the cosmos, pushing the boundaries of what we know and daring us to imagine what lies beyond. In the grand tradition of exploration and innovation, this revelation serves as a powerful reminder of the vital role that science and technology play in advancing our knowledge and inspiring generations to come. The journey of discovery continues, and with each new glimpse into the depths of space, we move one step closer to unlocking the secrets of the universe. So, how did the James Webb Space Telescope manage to capture such a breathtaking image? And what new mysteries have scientists begun to unravel about the Whirlpool Galaxy? Join us in this video as we explore the captivating story behind how the James Webb Telescope unveiled the very first, true, detailed image of the Whirlpool Galaxy, a cosmic marvel that has fascinated humanity for centuries. Since the dawn of civilization, humans have been driven by an insatiable curiosity to comprehend the world and universe around us. This deep-rooted desire to explore and understand has fueled countless ambitious endeavors, especially in the realm of deep space exploration. Over the millennia, our tools for gazing into the cosmos have evolved dramatically, from the humble beginnings of early optical telescopes used by ancient stargazers to the cutting-edge, multi-billion-dollar space observatories and probes we deploy today. The James Webb Space Telescope is the pinnacle of this evolution. Launched as one of the most sophisticated and powerful observatories ever created, it represents a monumental investment of time, expertise, and resources, all dedicated to expanding our cosmic horizons. Its extraordinary capabilities allow us to peer deeper into space and further back in time than ever before, capturing phenomena invisible to previous generations of telescopes. Throughout history, many esteemed institutions have led humanity's quest to explore the cosmos. Names such as NASA, the European Space Agency, and private pioneers like SpaceX symbolize the collaborative spirit and cutting-edge innovation that drive modern space exploration. Together, these organizations have paved the way for groundbreaking discoveries and technological advancements that continue to push the boundaries of what we know. The unveiling of the Whirlpool Galaxy image is a testament to the relentless spirit of discovery and the extraordinary achievements that arise when science, technology, and human curiosity unite. In the following segments, we will delve into how the James Webb Space Telescope accomplished this feat, the groundbreaking insights gained about the Whirlpool Galaxy's structure and star-forming regions, and what these revelations mean for our understanding of the universe. Stay with us as we journey through this remarkable chapter of cosmic exploration, uncovering the secrets of a galaxy that has enchanted astronomers for centuries. Many organizations have championed the exploration of the cosmos, advancing our understanding of the universe one discovery at a time. However, beyond the efforts of individual countries and regional space agencies, it is the shared human aspiration to unravel the mysteries of the cosmos that has sparked extensive international collaboration. These global partnerships have given birth to monumental projects such as the International Space Station, a symbol of what humanity can achieve when united by a common goal. Among these collaborative endeavors, the James Webb Space Telescope, or JWST, stands out as a groundbreaking project that brings together multiple nations and scientific communities in the pursuit of cosmic knowledge. Initially conceived as a successor to the iconic Hubble Space Telescope, the JWST was specifically engineered to operate primarily in the infrared spectrum. The specialization allows it to peer through cosmic dust clouds and observe celestial objects that are either too distant, too faint, or too obscured for any other space telescope. Equipped with highly advanced instruments that provide unparalleled resolution and sensitivity, JWST has revolutionized infrared astronomy. Its design incorporates cutting-edge technologies that enable it to capture the faintest signals from the earliest galaxies, star-forming regions, and planetary systems, offering a glimpse into the universe's distant past. The JWST project is the result of a remarkable international partnership led by the United States National Aeronautics and Space Administration, NASA, alongside the European Space Agency, ESA, and the Canadian Space Agency, CSA. This collaboration has pooled resources, expertise, and technology from around the world, exemplifying the spirit of global cooperation in space exploration. Together, these agencies have worked tirelessly to design, build, and launch the JWST, overcoming immense technical challenges to place this marvel of science in orbit. The success of this endeavor not only reflects the extraordinary capabilities of modern engineering, but also highlights the power of international teamwork in pushing the boundaries of our cosmic understanding. The James Webb Space Telescope is the result of an extraordinary collaboration between three distinguished space agencies: NASA, the United States National Aeronautics and Space Administration, the European Space Agency, ESA, and the Canadian Space Agency, CSA. Its name honors James E. Webb, a visionary former NASA administrator whose leadership helped lay the foundations for America's space exploration efforts during the Apollo era. The monumental responsibility of designing and constructing this revolutionary telescope was entrusted to Northrop Grumman Corporation, one of the United States' premier multinational aerospace and defense technology companies. With decades of experience in cutting-edge aerospace engineering, Northrop Grumman played a pivotal role in bringing the JWST project from concept to reality. At the core of JWST's extraordinary capabilities is its primary mirror, an engineering marvel composed of 18 individual hexagonal segments. Each segment is meticulously crafted from beryllium and coated with a thin layer of gold to maximize reflectivity in the infrared spectrum. When these segments are carefully aligned and combined, they form an enormous 21-foot wide mirror, roughly 3 times the diameter of the Hubble Space Telescope's mirror. This significantly larger aperture gives JWST a light collecting area approximately 6 times greater than Hubble's, enabling it to capture much fainter and more distant objects in the cosmos. The increased light-gathering power allows JWST to produce images of unparalleled clarity and sensitivity, unveiling cosmic phenomena that were previously beyond our reach. This massive mirror is complemented by advanced instrumentation that allows JWST to detect subtle infrared signals emitted by the earliest galaxies, newborn stars, and the atmospheres of distant exoplanets. Through this combination of innovative design and cutting-edge technology, JWST is poised to transform our understanding of the universe. The James Webb Space Telescope's impressive 21-foot mirror results in enhanced brightness, richer colors, and extraordinary levels of detail in the images it captures. Yet, JWST's strengths go far beyond creating breathtaking pictures of the cosmos. At the heart of its design lies a specialized ability to observe infrared light, a critical feature that sets it apart from earlier space telescopes. Infrared observation allows JWST to detect light in the orange and red visible spectrum, as well as mid-infrared wavelengths, which are invisible to the human eye and many traditional telescopes. This capability is essential for studying some of the universe's earliest celestial objects, whose light has been stretched or redshifted by the expansion of the cosmos. Many of these distant entities have redshift values between 15 and 20, meaning their emitted light has shifted so far toward the infrared range that only instruments sensitive to these wavelengths can observe them. To protect itself from the relentless and intense heat of the sun, NASA equipped JWST with a remarkable 5-layer sun shield. This sun shield acts as a thermal barrier, blocking solar radiation and preventing the telescope from overheating. Keeping JWST at an extremely low temperature is crucial, since any heat it emits itself could interfere with the sensitive infrared observations it needs to make. The sun shield ensures that the telescope remains cool enough to detect faint infrared signals from the farthest reaches of space with minimal background noise. The path to JWST's realization was long and fraught with challenges. The project officially began in 1996 with an initial budget of approximately $1 billion. However, technical design debates, engineering hurdles, and budgetary concerns led to repeated delays. Despite these setbacks, significant progress was achieved by 2005, when assembly of the telescope began in earnest. After years of painstaking construction and rigorous testing, the telescope was finally completed in 2016. Yet further test runs and managerial complexities continued to postpone its launch. Ultimately, it was not until December 2021 that JWST successfully embarked on its groundbreaking mission to revolutionize our view of the universe. Upon reaching its designated orbital position at Lagrange Point 2 in January 2022, the James Webb Space Telescope officially began its transformative journey into the depths of the universe. From this unique vantage point, nearly 1.5 million kilometers from Earth, JWST has been delivering breathtaking images and groundbreaking scientific data, shedding new light on some of the most mysterious and captivating objects in the cosmos. Since its inauguration, JWST has unveiled spectacular views of early galaxy clusters formed just a few 100 million years after the Big Bang, luminous and colorful nebulae where stars are born, and enigmatic black holes whose immense gravity warps space and time itself. These vivid, stunning images breathed new life into the field of astronomy, inspiring scientists and the public alike. It is important to note that the vibrant colors in JWST's images are not captured directly, but are carefully applied by scientists during processing. Since JWST primarily observes the universe in the infrared spectrum, a type of light invisible to the human eye, its raw images are essentially colorless and require sophisticated techniques to translate the data into colors that highlight different elements and features, making the observations more understandable and visually compelling. NASA unveiled the telescope's first fully colored image to the public in July 2022, and the result was nothing short of spectacular, exceeding even the highest expectations of the scientific community. Within just days of beginning its scientific operations, JWST made a groundbreaking discovery that sent ripples throughout the astronomical world. The telescope identified thousands of previously unknown galaxies, many of which are far older and more distant than any galaxies recorded before. These ancient galaxies, dating back to the earliest epochs of cosmic history, were so unexpected that scientists dubbed them the universe breakers. Their existence challenges prevailing cosmological models based on the Big Bang theory, prompting researchers to rethink and refine our understanding of the universe's formative years. This astonishing revelation was only the beginning of JWST's incredible contributions, opening an entirely new chapter in humanity's quest to comprehend the vast cosmos and the origins of everything we see around us. Subsequent discoveries by the James Webb Space Telescope have deepened our understanding of a wide array of cosmic phenomena, including groundbreaking revelations about elusive dark matter, the diverse worlds orbiting distant stars known as exoplanets, and even detailed views of famous space structures like the enigmatic pillars of creation. Now, JWST has astonished the world once again with its latest triumph, the unveiling of the first ever detailed, full-color image of the Whirlpool Galaxy. Located approximately 27 million light-years away from our solar system in the constellation Canes Venatici, the Whirlpool Galaxy, also known by its astronomical catalogue names Messier 51, M51A, or NGC 5194, is a captivating celestial marvel. Spanning roughly 77,000 light-years across, it is classified as a mid-sized spiral galaxy, distinguished by its stunning and well-denied spiral structure that makes it one of the most studied and visually striking galaxies in the cosmos. Interestingly, the Whirlpool Galaxy holds the distinction of being the very first spiral galaxy ever discovered by astronomers, setting a precedent for our understanding of galactic forms and dynamics. At its core lies a supermassive black hole, partly obscured by swirling dust clouds, accompanied by two ionization cones extending outward from its active galactic nucleus, regions where high-energy radiation ionizes gas in spectacular cosmic displays. What truly sets the Whirlpool Galaxy apart is its mesmerizing spiral arms, which twist gracefully to form the iconic whirlpool shape that has captivated astronomers and stargazers alike. These two prominent arms rotate in a clockwise direction. The one arm displays a curious deviation from the expected rotational angle, adding complexity to the galaxy's overall structure. Thanks to the unparalleled clarity and sensitivity of JWST's instruments, scientists have been granted an extraordinary view into the galaxy's stellar nurseries, regions where new stars are being born amidst clouds of gas and dust. These images reveal intricate details of star formation processes, shedding light on the life cycle of stars and the dynamic environments within spiral galaxies. JWST's unprecedented image of the Whirlpool Galaxy not only deepens our understanding of this iconic celestial wonder, but also exemplifies the transformative power of cutting-edge space technology to reveal the hidden secrets of our universe. Within the mesmerizing spiral arms of the Whirlpool Galaxy, clusters of newly forming stars are taking shape. Illuminated against a backdrop of swirling cosmic dust, the intricate spirals vividly resemble the familiar pattern of water swirling down a drain. With the spiral structures primarily made up of deep orange filaments of dust, interwoven with vast regions where material is notably sparse. The brilliant yellow spirals visible in JWST's exceptional ability to perform infrared imaging, which allows it to peer through cosmic dust and reveal features invisible to conventional optical telescopes. This stunning portrayal was crafted through a collaboration of two of JWST's most advanced instruments, the near-infrared camera known as NR-IR and the mid-infrared instrument or MIRI. Together, these tools combined their capabilities to produce a multi-layered and detailed image of the Whirlpool Galaxy, showcasing its beauty in a way never seen before. This innovative imaging approach took inspiration from a scientific initiative called FEAST, Feedback in Emerging Extragalactic Star Clusters, which aims to study star formation in distant galaxies. A NIRAM, a highly sensitive infrared imaging device, covers a broad spectrum ranging from near-visible light to near-infrared wavelength. It is equipped with 10 highly precise sensors and serves as the primary instrument responsible for focusing and controlling JWST's massive main mirror, ensuring sharp and accurate images. Meanwhile, MIRI operates in the mid to long infrared wavelength range and combines an infrared camera with an imaging spectrometer. This dual functionality allows it not only to capture detailed images, but also to analyze the chemical composition and physical conditions of celestial objects by examining their emitted spectra. By harnessing the complementary strengths of NIRCam and MIRI, JWST has opened a new window into the Whirlpool Galaxy, revealing the fine details of its spiral arms, star-forming regions, and cosmic dust with unprecedented clarity. This breakthrough exemplifies the power of advanced infrared astronomy to deepen our understanding of the universe and the processes that shape it. The image of the Whirlpool Galaxy captured by JWST's near-infrared camera, or NICAM, reveals striking dark red features that indicate the presence of warm, filamentary dust weaving through the galaxy's spiral arms. These dark red filaments are crucial in understanding the distribution and composition of cosmic dust, which plays a key role in star formation and the overall dynamics of the galaxy. In contrast, the mid-infrared instrument, known as MIRI, provides a complementary view by showcasing bright filaments nestled within seemingly empty cavities of the spiral arms. This gives a more dramatic and vivid representation of the galaxy's internal structure. Thanks to MIRI's unique capability for deep infrared imaging, it can detect specific light emissions from tiny dust grains, which glow brightly at mid-infrared wavelength. These emissions highlight regions where dust is heated by nearby young stars, making the invisible structures of the galaxy come alive in remarkable detail. By harmoniously blending the images from NIRSAM and MIRI, scientists were able to create a comprehensive and multi-dimensional portrayal of the Whirlpool Galaxy. This combined image captures every facet of the galaxy's complex anatomy, from warm dust clouds to bright ionized gas regions, offering an unprecedented view of its intricate nature. This remarkable imaging achievement not only deepens our understanding of the Whirlpool Galaxy itself, but also stands as a testament to the extraordinary capabilities of the James Webb Space Telescope. It demonstrates how advanced technology and innovative scientific collaboration can unlock new cosmic insights that were previously out of reach. The pioneering imaging of the Whirlpool galaxies is part of a broader observatory initiative known as FEAST, which stands for Feedback in Emerging Extragalactic Star Clusters. This ambitious project aims to unravel the complex and intertwined effects that newly formed stars have on their surrounding galactic environments. By studying these feedback processes, scientists hope to better understand how stars influence the evolution of galaxies, including star formation rates, gas dynamics, and the life cycle of cosmic dust. The FEAST project focuses on studying the effects that newly forming stars have on their surrounding environments during the complex process known as stellar feedback. Stellar feedback refers to the powerful energy and matter released by young forming stars, which in turn can trigger further star formation and significantly shape the surrounding interstellar medium. The vast mixture of gas, dust, and cosmic particles that fills the space between stars. Before the James Webb Space Telescope, astronomers primarily relied on powerful observatories such as the Hubble Space Telescope and the Atacama Large Millimeter/Submillimeter Array, ALMA, to study stellar feedback. While these instruments provided valuable insights, they lacked the ability to capture the depth, clarity, and range of infrared wavelengths needed to fully comprehend how stellar feedback operates and influences the intricate dynamics within the interstellar medium. Thanks to the synergy between JWST's near-infrared camera, NIRI, and mid-infrared instrument, MIRI, astronomers can now explore stellar feedback with unprecedented detail and precision. This powerful combination allows scientists to observe the energy released by nascent stars as it radiates through dense clouds of gas and dust, revealing complex and delicate structures that were previously hidden from view. Stellar feedback often manifests as energetic outflows, intense radiation, and powerful stellar winds that create intricate networks of luminous knots, bright, compact regions of gas heated by young stars, and cavernous dark voids, where gas and dust have been pushed aside or cleared out. These phenomena influence the birth of new stars by compressing surrounding material or dispersing it, thereby regulating the rate at which stars form and shaping the future evolution of their host galaxy. Through the detailed observations made possible by JWST, scientists are gaining transformative insights into how these feedback mechanisms operate on both small and large scales, shedding light on the delicate balance that governs the life cycle of stars and the evolution of galaxies across the universe. These luminous knots and expansive bubbles within the interstellar medium are a direct consequence of the powerful forces unleashed by young stars. This newfound insight enables scientists to deepen and refine their understanding of how stars actively shape and transform their cosmic surroundings, influencing the life cycle of galaxies on a grand scale. For decades, the Whirlpool Galaxy has captivated astronomers with its unique and captivating features, especially its distinctive spiral structure and its dynamic interaction with a neighboring dwarf galaxy known as NGC 5195 or M51b. This smaller companion galaxy lies adjacent to the Whirlpool Galaxy and has been significantly affected by the powerful gravitational forces exerted by its massive neighbor. The gravitational pull between these two galaxies has distorted M51b's shape, making it difficult for astronomers to definitively classify it as either a lenticular, spiral, or irregular galaxy. This ambiguity adds to the fascination and complexity of studying their interaction. One of the most intriguing aspects of the Whirlpool Galaxy is its striking spiral pattern, which deviates from the norm seen in most spiral galaxies. The galaxy boasts two prominent spiral arms that rotate clockwise, yet one arm notably diverges from the typical rotational path. This unusual characteristic is a direct result of the gravitational interaction with M51b, an event that occurred approximately 600 million years ago. This close encounter between the two galaxies not only altered the structure of M51b, but also caused significant distortions and asymmetries in the spiral arms of the Whirlpool Galaxy. These tidal forces triggered bursts of star formation and have continued to influence the galaxy's evolution ever since, providing astronomers with a natural laboratory to study the effects of galactic interactions and the complex processes that govern star birth and galactic morphology. The gravitational encounter between the Whirlpool Galaxy, M51a, and its companion, M51b, ultimately led to a partial merging of the two galaxies. As a result, massive and extended plumes of hydrogen gas now stretch outward from their cores, marking the regions where these cosmic titans interact most intensely. The largest of these gaseous extensions, known as the Northwest Plume, extends approximately 140,000 light-years from the center of M51a. This enormous plume exhibits a uniform reddish hue, indicative of diffuse hydrogen gas illuminated by the surrounding stars and energetic processes within the galaxy. Adjacent to the Northwest Plume are two additional prominent features, collectively referred to as the Western Plumes. Unlike the reddish tint of the Northwest Plume, these Western Plumes are distinguished by a striking blue coloration, likely caused by the presence of young, hot stars energizing the surrounding gas. The contrasting colors of these plumes highlight the dynamic and varied environments within the Whirlpool Galaxy and provide clues to its complex history. In a remarkable discovery made in 2015, astronomers identified two even fainter plumes named the Northeast and South Plumes. Although less conspicuous, these features add further intricacy to the galaxy's structure, underscoring just how complex and layered the Whirlpool Galaxy truly is. The existence of these plumes speaks volumes about the violent past and ongoing evolution of this cosmic marvel, reminding us that galaxies are not static entities, but are shaped continuously by gravitational interactions and star formation activity. Furthermore, both M51a and its companion M51b are members of a small galaxy cluster known as the M51 group. This group is considered a subcluster nested within a much larger and more elongated assembly of galaxies. Exploring and understanding the intricate connections and gravitational dances between galaxies within such groups provide astronomers with crucial insights into the larger scale structure of the universe and the forces shaping galaxy evolution. In the expansive field of astronomy, galaxies are classified based on their observable characteristics and behaviors. However, there is no single, universal system for categorizing galaxies. Traditionally, astronomers have catalogued galaxies using their coordinates, brightness, and spectral features, resulting in a variety of naming conventions and designations. For example, the Whirlpool galaxy is commonly identified by its catalogue names, such as Messier 51, M51, A, or NGC 5194. These identifiers serve as essential references within the astronomical community, facilitating detailed study and comparison across different galaxies. The Whirlpool galaxy, also known by its catalogue number, Messier 51 or M51, owes its name to the eminent French astronomer Charles Messier, who dedicated much of his career in the 18th century to cataloguing nebulous objects scattered across the night sky. Messier's catalogue aimed to help astronomers distinguish between permanent celestial objects, such as star clusters and nebulae, and transient phenomena, like comets. When Messier first observed this remarkable object on October 13, 1773, he noted it as a faint nebulous patch of light situated within the boundaries of the northern constellation Canes Venatici. At that time, with the limited technological capabilities of the telescopes available, this celestial entity was simply classified as a nebula, a broad term used for any diffuse or faint light source in space. The true nature of M51 remained a mystery for many decades. The astronomical community had yet to understand that what appeared as hazy blobs were in fact entire galaxies, massive collections of billions of stars, gas, dust, and dark matter bound together by gravity. This fundamental misunderstanding persisted until the mid-19th century, when William Parsons, the third Earl of Rosse, sought to push the boundaries of observational astronomy using his newly constructed Leviathan telescope at Birr Castle in Ireland. This telescope, boasting a mirror over 6 feet in diameter, was the largest and most powerful in the world at that time. In 1845, Parsons trained the Leviathan on Messier 51 and made a landmark discovery. He was able to resolve and sketch the spiral arms of the Whirlpool galaxy. This revelation was nothing short of revolutionary, as it was the first time astronomers had visual proof of a galaxy exhibiting a clearly defined spiral structure. This discovery challenged the prevailing notions of what nebulous objects were and helped shift the scientific paradigm toward understanding galaxies as complex systems, not mere nebulous clouds within our own Milky Way. The identification of M51's spiral arms opened new avenues for studying the structure and dynamics of galaxies. It inspired generations of astronomers to consider how such magnificent structures formed and evolved over cosmic time. The Whirlpool galaxy became a fundamental subject of astrophysical research, a nearby laboratory for probing the processes that govern star formation, galactic interactions, and the behavior of interstellar matter. Over the ensuing centuries, astronomers have meticulously documented the many fascinating aspects of M51. Its well-defined spiral arms, extending approximately 77,000 light-years across, host an array of stellar nurseries, regions rich in gas and dust, where new stars are born. The galaxy's intricate structure is marked by the interweaving of dark dust lanes, brilliant star clusters, and glowing regions of ionized gas, all arranged in a mesmerizing whirlpool pattern that visually resembles water spiraling down a drain. This distinct pattern distinguishes M51 from countless other galaxies and continues to captivate scientists and enthusiasts alike. A crucial factor in M51's intriguing morphology is its gravitational dance with a nearby companion galaxy, NGC 5195, also called M51b, a smaller dwarf galaxy that orbits and interacts with the larger Whirlpool galaxy. This interaction, believed to have commenced around 600 million years ago, has profoundly influenced M51's spiral structure. The gravitational forces between the two galaxies have triggered tidal distortions, the formation of extended hydrogen gas plumes, and bursts of star formation within the spiral arms. These dynamic exchanges not only shape the visual appearance of M51, but also offer insight into the broader cosmic processes of galactic mergers and evolution. Today, the Whirlpool galaxy continues to be a centerpiece in astronomical research, thanks to advanced instruments such as the Hubble Space Telescope, the Atacama Large Millimeter/Submillimeter Array, ALMA, and more recently the James Webb Space Telescope, JWST. Scientists can observe M51 in unprecedented detail across multiple wavelengths. These observations have unveiled new information about the life cycle of stars, the composition of interstellar dust, and the role of stellar feedback in shaping the galactic environment. Moreover, the Whirlpool galaxy serves as a stunning visual reminder of the vastness and complexity of the universe we inhabit. Its discovery and ongoing study exemplify humanity's relentless curiosity and the ever-expanding frontiers of scientific knowledge. From a faint nebula spotted by Charles Messier with a modest telescope over 2 centuries ago to a magnificent spiral galaxy imaged in exquisite detail by some of the most sophisticated space observatories ever built, M51 stands as a testament to the progress of astronomy and our enduring quest to understand the cosmos. As we peer deep into the vast expanse of the cosmos through the unparalleled lens of the James Webb Space Telescope, we are met with a breathtaking spectacle of celestial beauty and intricate complexity, the Whirlpool galaxy. This recently unveiled image is more than just a visual marvel. It is the culmination of decades of scientific innovation, cutting-edge technology, and the tireless dedication of countless astronomers and engineers. It offers us a profound and intimate glimpse into the very heart of this magnificent cosmic wonder, revealing details never before seen and sparking new questions about the universe we inhabit. Yet, the story of the Whirlpool galaxy is far from complete. Each new observation opens a gateway to deeper mysteries, compelling us to ponder the fate of relatively young galaxies and the dynamic nature of their gravitational interactions. The swirling arms of the galaxy, the intricate dance with its smaller companion galaxy, and the bursts of star formation occurring within its vast reaches all challenge our understanding and invite further exploration. What processes govern the birth and evolution of stars in such an environment? How do galactic collisions and interactions shape the cosmic architecture we observe? These are the questions that the Whirlpool galaxy, in all its swirling splendor, quietly poses. The James Webb Space Telescope stands as a guiding light in this quest, illuminating the darkest, most distant corners of the universe. Unlike any of its predecessors, JWST's advanced infrared capabilities allow it to peer through clouds of cosmic dust and gas, unveiling hidden regions of starbirth and revealing the faint glow of galaxies billions of light years away. It beckons humanity to journey deeper into space and time, unraveling the universe's long-held secrets and challenging us to expand the boundaries of our knowledge. In conclusion, the unveiling of the first ever detailed color image of the Whirlpool galaxy by the James Webb Space Telescope represents a monumental milestone in the field of astronomy. This historic achievement is a testament to the power of international collaboration, the relentless advancement of technology, and the indomitable human spirit of exploration. As we gaze upon the captivating whirlpool of stars, dust, and cosmic phenomena, we are reminded of the boundless mysteries that await discovery within the vast cosmos. The journey of the James Webb Space Telescope has only just begun. With each new revelation, it propels us further into the depths of the universe, inspiring wonder, curiosity, and a profound appreciation for the grandeur and complexity of the cosmos that surrounds us. This magnificent telescope not only expands our cosmic horizons, but also invites us all to share in the awe and inspiration of exploring the final frontier.